In section 3.6, I will be discussing how to solve polynomial and rational inequality problems. To do this, we will be using a number line technique. Again, there's lots of examples posted on the Canvas notes, so be sure to check that out after this video. Let's complete an example. Let's solve x cubed plus x squared is less than or equal to 9x plus 9. In order to begin solving, we must set our equation, or inequality in this case, equal to 0. So let's move the 9x and the 9 over to the left-hand side. So I'm going to get x cubed plus x squared minus 9x minus 9 is less than or equal to 0. I see 4 terms, so I'm going to go ahead and factor this problem by the cut in half technique. GCF out of the left is x squared, and I'm left over with x plus 1. On the right, I can pull out a negative 9, and I'm left with x plus 1. Continuing to factor, I see that both terms have an x plus 1, so pulling out an x plus 1, I'm left over with x squared minus 9. Keep on factoring. Remember, x squared minus 9 is difference of squares, so I have x plus 1 times x minus 3 times x plus 3 is less than or equal to 0. Next, I need to find the zeros of the polynomial. And so setting each expression equal to 0, I'm going to get x equals negative 1, x equals positive 3, and x equals negative 3. Now here comes the number line technique. I'm going to draw a number line. On my number line, I'm going to put my 3 zeros. I have negative 3, negative 1, and positive 3. Next, I need test points in between each region. So I can test, for example, negative 4, negative 2, 0, and positive 4. I'm going to plug the test points into this function I've just circled. And I'm going to test. Do I get a positive number or a negative number? Remember, I want all the numbers less than or equal to 0, which means I'm looking for the negative numbers for this particular example. So let's start by plugging in negative 4. So I'm going to have negative 4 plus 1 times negative 4 minus 3 times negative 4 plus 3. Now, little trick, I don't have to actually do all the math and solve. All I care about are the signs of the numbers. So here we go. Negative 4 plus 1 is a negative number. Negative 4 minus 3 is a negative number. Negative 4 plus 3 is also a negative number. So, what is a negative times a negative times a negative? Again, that'll be negative. Let's plug in negative 2 next. Negative 2 plus 1, negative 2 minus 3, negative 2 plus 3. Negative 2 plus 1 is a negative number. Negative 2 minus 3 is a negative number. Negative 2 plus 3 is a positive number. So it's a negative times a negative times a positive. You'll get a positive. Plugging in 0. 0 plus 1 times 0 minus 3 times 0 plus 3. 0 plus 1 is positive, 0 minus 3 is negative, 0 plus 3 is positive. So what is a positive times a negative times a positive? Whole thing will be negative. And running out of space, so let me come up here, plugging in 4. I'm going to get 4 plus 1, 4 minus 3, 4 plus 3. 4 plus 1 is positive, 4 minus 3 is positive, and 4 plus 3 is positive. So again, what's a positive times a positive times a positive? You'll get a positive. Now, it happened to alternate on this example where it went negative, positive, but you can't guess that that's going to happen every time. It is possible to get negative, positive, positive, negative. There can be any combination of signs. So you really do have to plug in all the test points. I know it's a bit lengthy. So we're almost done at this point. Again, my problem was, where is my polynomial less than or equal to 0? So again, less than or equal to 0 means I'm looking for the negative regions only. I don't care about the positive ones. And now based on that number line, we can put our answer together in interval notation. So here we go with the final solution. The negative region goes from negative infinity to negative 3. And because it's less than or equal to, I'm going to use square bracket. And, or union, including the region between negative 1 and 3. Again, because this is less than or equal to, we're going to use square brackets. Remember, infinity is always round.